Welcome back to Differential Calculus. In this video, we're continuing our tour of ways of simplifying derivatives with the product and the quotient rule. As the name suggests, these are going to be tools for taking derivatives of the product of two functions or the quotient of two functions, respectively. We'll start off with the product rule. If I get my head out of the way, once again, I'm just going to give us the usual definition here. If you're interested in where these come from, I'm more than happy to share those with you, but we don't really need it. So for the sake of time, let's just jump right into. If we have two functions, u of x and v of x, which are being multiplied together, to take the derivative of the product, we are going to take the derivative of the first times the second plus the first times the derivative of the second. So u prime of x times v of x plus u of x times v prime of x. All right. This is multiplication and addition. You can write these in other orders if you would like. For reasons that will become a little bit clearer later in the video when we're talking about the quotient rule, I think it's worth taking the time to memorize it in this order. But I will point out that I sometimes see this written as u times v prime plus v times u prime. And mathematically, it's the same, right? I just swapped the order of the two terms, and I swapped the order of the multiplication in this term. It's the same rule. It's written in a slightly different way. But derivative of the first times the second plus the first times the derivative of the second is the way that makes the most sense to me. And if I jump right into an example of this, we can take the derivative of, say, x times the square root of x plus 1. Writing this out in pieces, it's going to be the derivative of x times the square root of x plus 1 plus x times the derivative of the square root of x plus 1. Right. Derivative of x is just 1. That's really easy. The derivative of the square root of x plus 1 is a little bit more involved. You are going to need to use the chain rule on that. But the derivative of a square root is 1 over 2 times that square root. We've done that before. You can use the power rule to get that. And then you multiply by the derivative of x plus 1, which is just 1. So yes, everything comes into play very often in these sorts of problems. We're talking about the product rule, and then we realize that one of the things we're taking a product on is itself a composition, so we have to use the chain rule for that. These can get pretty deep pretty quickly. This one is not all that bad. And I'll leave it at that. Square root of x plus 1 plus x over 2 square root of x plus 1. If you gave me something like that on an exam, I would be very happy with that. But I will point out that if you're following along in a book and you're checking your answer in the back of the book, sometimes they will go a little bit crazy doing some algebra from here. If I take that first term and multiply top and bottom by 2 root x plus 1, I can write it as 2x plus 2 over 2 times the square root of x plus 1. And then simplify from there to get 3x plus 2 over 2 times the square root of x plus 1. So if you're checking your work, you might come across it written as that solution instead. Again, for my purposes, I'm not picky. If you gave me the one that I came first, the one that's circled, I would be happy with that. That would receive full credit on one of my exams. but you should at least be able to recognize when you have things that are this different, right? Sum that has a fraction in one of them, a fraction that has a sum in the numerator, your algebra brain should be kicking in and saying, wait, can I do some rearranging to get from one to the other? And you can try, right? You can try to work through the algebraic manipulations, see if you can get there, because those are the same solution, but you have to choose one of them to write down. The product rule is also incredibly useful if we want to take a higher order derivative of something involving uh, a product. So if I want to take, say, the derivative of the square root of x squared minus 1. I have here the second derivative marked out, and I generally do that in two steps. I'm going to take the derivative of x squared minus 1, which is going to be 1 over 2 square roots of x squared minus 1 times the derivative of the stuff inside, which is itself 2x, right? Using the chain rule for that step. And yeah, let's get rid of these extra factors of 2. They don't actually need to be there. And we can write this now as the derivative of 1 over the square root of x squared minus 1 times x. This is a product. We're going to have the derivative of 1 over the square root of x squared minus 1 times x plus 1 over the square root of x squared minus 1 times the derivative of x. Derivative of x is just 1. That's nice and easy to deal with. This is a bit of a mess. Right? That is u to the negative 1/2. So the derivative there is going to be negative 1 over 2u to the 3/2. Right? We've done that particular one in a previous video as well, but you can work that out using the chain rule. To all told, go from here, and we're going to say that that's going to be negative 1 over 2 times x squared minus 1 to the 3/2 power times the derivative of x squared minus 1, which is 2x, times the x that's already there, plus 1 over the square root of x squared minus 1. And I'll simplify a little bit. X squared over x squared minus 1 to the 3/2 plus 1 over, since I have that first one as 3/2, I think it looks a little bit nicer to write the second one as 1/2. But again, it doesn't matter. It all works the same. I'm kind of happy leaving things like that. I will once again point out that you could do a little bit more work to clean up. You can multiply that second fraction top and bottom by x squared minus 1, and things would actually clean up pretty nicely. But I'm going to leave it like that because I'm lazy. That takes us to a quotient, the derivative of u of x over v of x, which is actually what we had in that last problem, if you think about it. So for once, I'm going to actually show you the derivation here because I think it's kind of interesting. And for me, it helps me remember how this works and why it works. U over v is the same thing as u times 1 over v, or u times v to the negative first. Using the product rule now, this is going to be this is going to be the derivative of u times v to the negative first plus u times the derivative of v to the negative first. Then using the power rule, negative v to the negative second, and using the chain rule, that gets multiplied by v prime. Cleaning up a little bit from here, this is u prime over v minus u v prime over v squared. And if I multiply that first fraction, top and bottom, by an extra factor of v, I get u prime v minus u v prime over v squared. And that's the form that's generally given to us for the quotient rule. The derivative of u over v is u prime v minus uv prime over v squared. Notice in the numerator, that's the same form that we had for the product rule. I just switched addition for subtraction. I then made things more complicated by putting a v squared in the denominator. But the quotient rule really is just the product rule in disguise. You can always go back and use the product rule and never even touch the quotient rule if you so desire. I find that there are certainly problems where having the quotient rule is more useful, generally involving rationals with some nasty polynomials in numerator and denominator. So for example, if I want to take the derivative of x cubed minus x over x squared plus 1, I'm going to split this up. U of x is the numerator, x cubed minus x, and the derivative is 3x squared minus 1. V of x is the denominator, x squared plus 1. V prime of x is just 2x. And with that, instead of trying to split up things any other way, I can just use the quotient rule. U prime times v minus u times v prime all over v squared. All right, let's clean this up at least a little bit. We can distribute. We'll have 3x to the fourth plus 3x squared minus x squared minus 1 minus 2x to the fourth minus a minus is plus 2x squared all over x squared plus 1 squared. Now let's see, we've got 3 and minus 2 x to the fourth. So that's just 1 x to the fourth. We've got 3 minus 1 plus 2, which all told is going to be plus 4 x squared. And then we've got a minus 1. That's still all over x squared plus 1 squared. If I could factor that numerator and see if anything would simplify, I would try, but it doesn't look like that's going to happen in this case, so I will leave well enough alone and call that my solution. I haven't looked at that last step yet this video, but I would like you to find the derivative and use it for writing the slope of a tangent line. Right? So I have a function here. Y is x minus 1 over 2x plus 1. You will need to find the derivative of this function in general. And then once you have that, you can evaluate the function and the derivative at the point x equals 1 to find the slope of the tangent line, the point you're going through, and use that to write the equation of a tangent line. Right, take a couple of minutes, see what you can do with that, and I'll see you in the next video.